you can bear with me. Now, this is the story of a very small group of concerned volunteers who were worried about their watershed and had gotten help with their watershed by partnering with governments, universities, with university municipalities, and other entities. Next, please. I work with the Pompaston Creek Watershed Association. We are a volunteer organization that was formed in 1963. Our mission is to protect and conserve the natural resources of Pompaston Creek through scientific investigations, education, and research. We have three basic program areas. We do a lot of education, which is usually based on our data. We do education with schools, community events, and with our municipalities. We also do some restoration work, and we have a monitoring program, volunteer monitoring program, where we monitor water quality. We also do biological assessments and stream visual assessments. Which is, if anybody was in here for Danielle, how many people were here for Danielle's talk? Danielle Robertson. Yeah. So she talked about the 4 different tiers. Our biological and stream assessments are the lower tiers, A and B probably, but our water quality monitoring is now at a tier D level. And that's what I'm going to talk about now. So the next slide, please. This is just a location map. The Pompaston Creek is a tributary to the lower Delaware River. And it's a small creek, about 9 square mile watershed. It contains parts of 4 municipalities, Morristown, Minton, most of the watershed, a little bit of Delran, and a little bit of Riverton. And it flows into the Delaware near the Rancocas Creek, and also very close to the New Jersey American Water Company surface water intake, which a lot of us drink. The Delaware River, as well as groundwater. Next one, please. This is a map made by Rutgers Water Resources Program using the DEP GIS coverage. And the pink or orange color is urban land use. The watershed is approximately 80% urbanized, and that's urban suburban. Okay. Next slide, please. So the challenges that we have in this watershed rise from the heavy development that's there. There are more than 200 stormwater outfalls that flow into this little creek, and they cause, the heavy flows cause erosion. The erosion later settles out as sedimentation downstream. The stormwater is polluted. We get flooding from excessive runoff and excessive impervious cover. We have a lot of sanitary sewers that run along the creek and often cross the creek. When the ones that cross the creek, occasionally they will develop leaks, or during periods of heavy rainfall or high groundwater, we'll get infiltration and inflow into the sanitary sewer, which results in stormwater and sewage coming out of the sanitary sewer. We also have the typical problems with pet waste, even though it's state law that we have to collect dog waste. A lot of people collect it and throw it in the stream via the storm sewage. So there's a lot of things going on there. The use of fertilizers and pesticides, especially in a lot of the neighborhoods that have large lawns. And trash, there's a phenomenal amount of trash in this little small creek. So go ahead. Bear with me these next 3 slides. I want to go over a little bit of the evolution of our volunteer monitoring program, just so that you have an idea of how many different groups we've gotten help with. And you just heard the quality assurance talk, and Danielle, I'm sure there have been other talks, where you're supposed to start with your study design, you're supposed to start with your question, you're supposed to think about all this stuff. Well, we started with the question, but everyone, in the beginning, we maybe did things a little bit backwards. But all right. So in 1998, way back in 1998, when we were not nearly as computer literate as we are now, and the internet was not quite as extensively used, my son was a Cub Scout, and our creek had a ton of trash in it, and I wanted to know if the water was going to be clean enough to take the Cub Scouts in to help clean up the trash. So that was the question that we started our monitoring program with. And And in about 1999, I think it was, that New Jersey DEP started their watershed management initiative, and they brought stakeholders to meet with them, and this was all a volunteer thing, except for the DEP people. But there was a lot of information exchange going on there, and it was a good program. A couple of years after that, funding dropped out of that. But it was easy to find out that when I asked this question, that the DEP was not doing any chemical or bacteriological monitoring on the creek because it was too small. And they were doing macroinvertebrate assessment, which is their bioassessment, on the creek every 5 years. That was the data that was being collected, and that showed the creek to be moderately to severely impaired for aquatic health. So the next thing we did was I contacted the Delaware Riverkeeper Network, and they, gave me a little training with kits, and we started monitoring monthly for using kits for pH, temperature, dissolved oxygen, nitrates, and phosphates. Because I was interested in the bacteria and having children in the stream, I also was collecting for fecal coliform and sending that out to a certified lab. We did not have a quality assurance plan at this point. We just had help from we were following Riverkeeper Network protocol. So, and the next one? Yeah, thanks. So we collected a little bit of data, a couple of years, and fecal levels would spike sometime, and between that data and the data that the state had collected on aquatic life, we were concerned about the stream not being clean enough. So we applied to the DEP for a 319H grant, a non-point source pollution grant, and we got that grant. The Watershed Association got that grant to do some stream bank restoration and to retrofit for stormwater detention basins in the watershed. So that was fun. That was a lot of work. We got a lot of volunteers involved at that time. And meanwhile, we kept collecting data. And in 2001, between 2001 and 2003, pretty rapidly, our fecal coliform values started routinely exceeding the surface water quality standards. So 74% of our samples during that time period exceeded the surface water quality standards. So, something was changing, and it was a problem. So I sent the data with a little report to the DEP and asked them if they could accept our data and use it to put the Palm-Heston Creek on the 303D list. Does everybody know what that is? Does everybody not know what that is? Okay. So the integrated reports, did you hear about that before? The states have to all produce integrated reports on their water quality, on their surface waters. 303D list is the list of waters that don't meet the standards. Okay. So I asked them to put the creek on the 303D list and to help do some sampling. So I didn't start until 3:15. I gotta have more than 2 minutes left. I usually 10 minutes. Okay. So let's see. Right. So I sent the data to DEP. I asked them to help us. They said, we can't use your data because you don't have a quality assurance plan, and it has to be not high enough quality data to use for regulatory purposes. Okay, and we won't sample because it's too small. That was really disappointing, but we figured, well, how do we have to, how are we going to make it so that it can be accepted? At that point, we got help from the Watershed Institute. Thank you, Elise and Laura, before you. We got a small grant to help us develop a quality assurance plan, pay for some of the sampling because we were now switching to laboratory samples, and I said to develop a quality assurance plan. So Rutgers helped us, gave us the technical expertise to develop the quality assurance plan, and I think I can go to the next slide. From 2004 to 2008, we collected and had analyzed by the laboratory fecal coliform and then E. coli. Standard change. Phosphorus, nitrate, nitrogen, total suspended solids, and we did field parameters also. So, and we got another grant from the Watershed Institute for a couple more things, including a meter for future monitoring. But by 2008, we had analyzed most of the that 4-year period of data for which we had a quality assurance plan. The exceedances, I will go to them in a second. There were exceedances. We turned the data into the DEP again and finally got the success of getting the creek switches on the 3D list. Now, that's not really a happy thing, but it was okay, good, our water's bad. But it's good, maybe we can get some help to get the water cleaned up. And meanwhile, we were also working with Rutgers. I'll get back to that next slide, please. We had 2 sampling sites, one in the upper portion of the watershed, one in the bottom portion of the watershed. Next slide. This is just a table of the major issues that came up with our monitoring. In the upstream, in both upstream and downstream sites, total phosphorus exceeded the criteria by the standards by 23 and 34%, getting worse as you go downstream. Fecal coliform and E. coli both exceeded the standards about at least 60% of the time. And we had some problems with dissolved oxygen dropping down too low in the lower part of the watershed, 14% of the time. Next slide, please. So phosphorus, one problem that we had when it was higher in the summer, it caused profuse algae to grow in the stream. It was also high after we collected samples after storms, and it's higher downstream and upstream. We figured the sources of the phosphorus in the watershed were probably fertilizers. There's a picture of some fertilizer granules on the street next to the grass, and you also see them along the sidewalk, and waste. And that picture in the lower right-hand corner is actually toilet paper that's left over on the sidewalk after one of those events where we had a lot of rain and the sewage came up out of the, too much storm. And we don't have a combined sewage overflow system. This is just infiltration and inflow getting into the sanitary sewer where it shouldn't, and causing the stuff to come out of the sanitary sewer pipes. Next slide, please. Bacteria, similar stuff. We found it to be higher in the summer than the winter. We had the DEP was kind enough to do some bacteria source tracking for us for a year during our sampling, and this was done by the Leeds Point Laboratory. And what they found wildlife sources in all 26 of the samples they analyzed. They found human sources in 7 of the 26 samples that they analyzed, and domestic animal source in 6 of the